All right, can we get someone get the lights over there and all right? All right, so I was thinking about where we are in the class and looking at our schedule here. And today we're supposed to review, and then Thursday's supposed to be in the exam. That's what we had talked about last week. So I'd like to just go through the review of what the exam would be, and plan on taking the exam on Thursday. So like I had said before, it's not going to be many problems. So they take a while. So let's just go through just one at a time, one problem at a time, and see how long it takes us, okay? So we'll call this the Exam 2 review. One of the reasons why I want to try and get this exam done this week is because, well, it's on the schedule, but midterm grades are due next Monday, I believe. So I'm supposed to post where you are on Monday. So, having a grade for you on Thursday, that would help indicate where you are in the class. So, all right, Exam 2 review. All right, the first question that you should anticipate having is something like sketch f of x equals 3 x plus 1 squared minus 8. Yeah, that's good. May as well break your calculator out because you're going to need it today. All right, so now I'm going to give you as much information as I can today about what to expect. I will not, however, guarantee this order. Okay, so I'm not going to guarantee you number 1 is just like this, all right? But I guarantee that a problem like this will be on the test. Make sense? Okay, so you are going to have to look at that, and you're going to have to know how to do it. What I will not accept is you getting your calculator, typing it in, graphing it, and drawing me your little window that you see in your calculator and being done, right? I expect steps. I'm not going to tell you what the steps are on the test because you have a cheat sheet. So by me going through this review, pretty much everything you see me do is what I expect to see you do. That sound fair? Okay. So you first have to recognize what it is we're looking at, and that will dictate what you do from there, right? So anybody recall what this is? It's a quadratic function. Which form is it in? Remember quadratic functions, we looked at them in 2 different forms? It is a 50-50 shot, right? This is quadratic in standard form. Yep. So this is in standard form. Now, I don't need you to tell me that, because I'll know from the work you do whether or not you realize that or not. But it might, won't hurt you to just identify it. All right, so here's what I would expect you to have. What are the steps for graphing a quadratic function? So what was the first step for graphing quadratic functions? Okay, does it open up or down? Opens up. Why? A is 3, which is greater than 0. So you're identifying the number out in front, right? A is 3. It's a number bigger than 0. Anytime it's bigger than 0, it opens up. It would open down if it was negative, right? Okay, that's first step. What's second step? Vertex. So to get the vertex, all we need to do is identify what h and k are. And when it's in standard form, that process is easy to do, right? Relatively easy. All we have to do is look inside the parentheses at that positive 1. H is always going to be the opposite of that, right? So h for us is negative 1. And then k is the number out by itself, including the sign, so negative 8. That's it. So step 3 is just to do a quick sketch. Did I say quick or rough? I don't remember what I said. Rough? I don't. Quick sketch? Doesn't matter. Okay, quick sketch. Now, why are we doing a quick sketch? Yes, what's the question?
If we change signs for the negative, like for the 1,
Uh-huh.
why did we not change the sign on the X?
Because that's just the way it always works with Vertex. The H is always the opposite. The K is always what it is. Now, if you want to know why, we can talk about that later, like after class or something. Okay, next thing. Quick sketch. I start with my vertex, right? So I'm going to go to the left 1, down 8. There's my vertex, and I open up, right? And since I do open up, I know I'm, in this case, going to have 2 X-intercepts. So I go ahead and try and find them now. So how do we find X-intercepts? Set it equals 0. So I'll do that over here. 3x minus 1 squared minus 8 equals 0. Where? Oh, yeah, plus 1 in here. There we go. Thank you. So whenever we're in standard form, what we do is the same for when we're trying to get X-intercepts, right? We don't use quadratic formula. We don't factor. We use the square root property. So we try and get that parentheses by itself. So we'll first move the 8 to the other side. Divide by 3. And then square root. Now, I'm going to need to know where this is on a number line, right? These are my X-intercepts, so I may as well go to a decimal now. I'm going to go ahead and take 8. Uh-oh. No, my batteries are dead. It can't be. No, how about you get it for me? Can you do 8 divided by 3? Oh, man, thank you for volunteering, though. 2.66. Okay, 2.6. We'll say 2.66 or 2.67. How about we just round it 2 decimal places? 2.67. Now take the square root on both sides. So I take the square root on the left. I take plus or minus, right? Square root of 2.67. So who's going to give me square root of 2.67? Not all at once, please. What is it? 1.63. What does the left side become? X plus 1. So I have x plus 1 equals, say it again, what was it? 1.63. Okay, good enough. Plus or minus, don't forget that. Like I just did. And now, to get x by itself, you subtract 1. So I'm going to have 1 plus or minus 1.63, and then I'm going to subtract 1 from that. That means I have to do both the positive and the negative, right? So I'll do the positive here. I'll do the negative here. So if I make that a positive 1.63 and I take away 1, I get 0.63. If I take it negative 1.63 and take away 1, I get negative 2.63. Do you all agree? Okay. These are our X-intercepts, right? What's next? Y-intercept. How do we find the Y-intercept? Okay, so plug 0 into the function. So 3, 0, that's x plus 1 squared minus 8. What does that turn out to be? Careful with that inside. 0 plus 1 is 1, isn't it? 1 squared is 1. 3 times 1 is 3. So 3 minus 8 would be -5. That's your y-intercept. So we have our vertex, our x-intercepts, our y-intercept. And now we're ready for the sketch, aren't we? The graph. Here we go. Do I need to go back or? Yes, go back real quick. I'm kind of quick there. What are some things you have to pay attention to when you graph? Make sure it passes the vertical line test. Make sure it looks symmetric. And make sure it doesn't look like a V. No sharp corner, right? So I'll start. I'll do my graph in black. -1, down 8. 1, 2, 3, 4, 6, 7, 8. There's -8. So there's my vertex. My x-intercepts were at -0.63. Oh, it was positive? Okay, good. Positive 0.63 and -2.63. So -2.63 is a little bit to the left of -2.5. I also have a y-intercept down at -5. I'm going to put my axis of symmetry in here just to help me graph. I know my graph has to be symmetric to that line. If you want to do that on the test, that's fine. Just make it a dotted line. All right, don't, because if you make it solid, it might look like it's part of your graph or something. I'll make my U at the bottom first. Oh no. And then the other side. Okay, that would give you full credit on the exam. So the way I grade this, just so you know, the first thing I do is I look at the graph. If the graph's right, that means that your information was right. So then I go, even if your graph is right, I then go look at your information. Very rarely do I start by looking at your information first, then go to the graph. So what I would do is I look at this, then I go back. I look for, whoa, where is it? I look for the y-intercept. I look for the x-intercepts. I look for how you got the vertex and how you got up or down. Up or down's kind of a gimme, but I want to see it, all right? Questions? All right. Okay, next question would be something like sketch f of x equals -x squared plus 4x plus 7. Same thing, right? Quadratic function, non-standard form. So whenever you have non-standard form, right, just going to put quad non-standard. Whenever you have a quadratic and non-standard, the vertex is the hard part, right? The vertex is the challenge. And the x-intercepts too, because you have to sometimes use quadratic formula if it doesn't factor. So let's move through this. First step, it opens down, right? It opens down because A here is what? -1, that's less than 0, so we know the graph opens down. All right, second step, vertex. Just curious, does this seem like somewhat fresh in your head still, or is this like way, way gone now? Or how do y'all feel? Somewhat? Okay. All right. Vertex, HK. So to get H, I will use the formula, which you should have on your cheat sheet, right? We talked about cheat sheets. One sheet of paper, front and back, anything written down except no worked out problems. So you could write H equals negative B over 2A. That's fine. For us in this problem, that would be negative 4 over 2 times, careful, 2 times negative 1. That means you have negative 4 over negative 2, which gives you 2. Now, I do promise you on the test that your vertex will be at an integer. Because I think I may have given you a problem to do on your own where that vertex was a decimal. I don't remember if it was a fraction or something. I'll make sure that they're nice integers for the vertex. Can't promise you the same thing for the X-intercepts. Okay, how do you get K? Plug H into the function. So you're going to plug 2 into the function. That's negative 2 squared plus 4 times 2 plus 7. That's negative 4 plus 8 plus 7, which is 11. I would just say be careful on this part right here with that negative. Because that negative sitting in front of the x squared way up in the function, that negative in front is like a negative 1. It comes in after you do the squaring. So you square whatever it is first, then you bring the negative in. You're not squaring negative 2, in other words. If you mess that up, it's going to throw everything off, right? Well, at least your vertex will be wrong. All right, so we have a vertex, don't we? Actually, our vertex is the point 2, 11. Now we'll do a quick sketch to try and get our X-intercepts if we have them. And I can pretty much guarantee you're always going to have at least one X-intercept on the test. So I'm going to go out 2, up 11, and it opens down. So I don't really need to pay a whole lot of attention. To how good that looks, just that I can determine I have X-intercepts. And again, I'll have 2 of them, right? I do expect to see that though, okay? Don't be like, oh, well, he told me there will always be 2, so I'm just going to skip that. I want to see the process. So now I'm going to set the function equal to 0, right? Now, at this point, you have the freedom to solve that any way you want. So you could use factoring, if factoring would even work. Or you could use quadratic formula. Quadratic formula will always work, right? If you don't like that negative sign in front of x squared, you can multiply everything by negative 1 to make it positive. It's totally up to you at this point. I'm going to use quadratic formula because it won't factor. Quadratic formula says that the solutions are going to be, you remember the formula, right? Negative b, I mean, you may not remember it, but you know what I'm talking about? Negative b plus or minus, all that stuff. So negative b is negative 4 plus or minus the square root of b squared, which is 16, minus 4 times a, which is negative 1, times c, which is 7, all over 2 times a, which is negative 1. So go back and refer to the formula, you know, that you have written down somewhere, or just Google quadratic formula. Negative 4 plus or minus square root of, let's see what we get in there. That should be 16 plus 28. 44, square root of 44. all over negative 2. So I need someone to get me the square root of 44, please. It's like 6 point something. 6.63. All over negative 2. Which equals, now I'm going to do my plus and my minus. Oh yeah, you cannot use your phone on the test. So make sure that you have a calculator. I'm going to use my phone because my thing's dead. But. So first thing I'm going to do is negative 4. I'm going to do the plus 6.63, then divide by negative 2. Now when you do that, you have to do the whole top first, right? Negative 4 plus 6.63 divide by 2. So that's just 2. Oh, no, that's not 2. It's 2.63 divided by negative 2. So negative 1.3. Good. Next one is negative 4 minus 6.63 over negative 2. So that's negative 10.63 over negative 2.2, or sorry, negative 2, which is what, 5.3-ish? Is that right? Okay. You could say 5.31, 5.32, but like we said, our graph isn't that accurate anyway. So we don't want to get bogged down with that too much. So there are our two X-intercepts. All right, the Y-intercept is next, and Y-intercepts on non-standard form are the easiest to get because when you plug in 0, you always get that number that was hanging out at the end, right? 7. But this is actually what you're doing. You're just plugging 0 in. So everything dies off except that number at the end, so 7. All right. Graph time. Here we go. My my vertex was 211 or 211. Yeah, it's a band, isn't it? Positive 2? Okay. 4, 5, 6, 7, 8, 9, 10. Has anyone ever heard of 211? Or am I that old? 211? No? Damn. Yeah. How about Incubus? Same era. Okay. I'm saying 211 was in the same era as Incubus was. All right, there's my vertex. And then X-intercepts were negative point what? 1.3, so a little bit past 1. Well, actually a lot of it. 1.3? Close enough. And then the other one was where? So 1, 2, 3, 4. Here's 5. The more labeling that you do, the better. All right. I don't have to have every single point labeled, but you know, the more that I can tell you know what you're doing, the better off you are. And then the Y-intercept was 7. So that puts me here. Here comes my axis of symmetry. Put my little U at the top. That kind of forces me to not draw a V. That's why I always like to put that little U at the top. Come on, you can do it. Connect the dots. Old school kindergarten style. Come on. There we go. That kind of looks like a V, but I'll let it go. I might have to dock myself a few points on that. There we go. That's a little better. All right, that's it. That's the first two, okay? Now, we've taken 30 minutes to do 2 problems. All right, the third type of problem would be something like sketching a polynomial. So since I don't have my calculator, let me make up a problem real quick. This might take me just a second. So that's what it's going to factor to be, but okay, here it is. F of x equals negative x to the 5th plus x squared plus 22x. Oh, wait, hold on. That should be x to the 4th. 22x cubed minus 40x squared. Before I get through too much of this, let me just double check my work here. I would hate to go, you know how long these problems are, so I don't want to go too far. And so negative plus negative 40. All right, that's it. All right, so sketch this. So you look at this, you should identify this as a polynomial. Now, last class I handed out a cheat sheet, right? Not a cheat sheet, a formula sheet. Did anybody not get that? I might have some extras here. They were free last time. They're $5 today. No, I'm just kidding. Anyone else need one? These were the steps for sketching polynomial and rational functions. And you're allowed to have this and another sheet as your cheat sheet, but you can't write anything else on this. So you can't use the other side of this. Yes, these are very important documents. All right, let's go through this. Come on, we gotta crank this out. Now I'm going to follow the steps on here because this might be what you use most likely. So step A is to find the degree of the polynomial. Is it odd or even? So degree is 5, and that's odd. It's very odd. And then the leading coefficient is -1. Which is negative, right? And then part C, determine the left hand and right hand behavior. So I even give you the table. I mean, this is great. What happens when you have an odd degree and a negative leading coefficient? It goes up and then down. And in the middle, we don't know. So I would like to see that on the test. I mean, that's not, you get yourself some points just doing that, right? All right, part D. Find the zeros, or the X-intercepts, they're the same thing, and the multiplicities. That means the powers of the factors. If the multiplicity or power is odd, you cross at that 0. If the power is even, you bounce. So I pretty much tell you all that already in the steps too. So to do that, though, we have to actually set the function equal to 0 and try and factor it. Solve it, right? Solve the equation. So how are you going to factor this? Grouping, yeah, won't work. But before grouping, GCF. X squared will come out, but even better than that, negative x squared. Because You always want to try and leave that first term when you factor out, you want to leave that first term positive. So pull a negative x squared out. What that does is it turns it into a positive x cubed, a negative x squared, a negative 22x, and a positive 40. So all the powers come down by 2, right? And all the signs change. But do not forget about this lowly little negative x squared that sits out front. Always gets left behind. Now we have to try and factor out this stuff in here, this yellow part. So to do that, you try grouping, not going to work. So therefore, you're going to need to use synthetic division. And also notice that in this problem, the number in front of x cubed is 1, which means you only have to create that one list. And on the test, I would expect the same thing. I'm not going to have you do that weird 2 lists where you have fractions. I'm just going to avoid that. Oh, no problem. No problem. All right, so here we go. Synthetic division. My list. I do need to see your list. It should be all the factors, positive and negative, of what number? 40. Okay, so 1 and 40. 2 and 20. 4 and 10. 5 and 8. That's it. Right? 6 doesn't work, 7 doesn't work, and then once you make to 8, you've met in the middle, you're done. So we've got our list. Now we try our synthetic division on that yellow part, right? What do I put in here? 1, negative 1, negative 22, positive 40. And then I said, as long as you start at the beginning of your list, smallest to largest, it'll happen within the first 4 or 5 tries. So I don't remember what I used to make this, so I'm just going to start at 1, and I'm just going to write these down real quick. 1, 1, 0, 0, negative 22, negative 22. Doesn't work. I'll do negative 1 next to it. I'm expecting that you could do these on your own, given enough time. That doesn't work. 2's next. So I did 1, then negative 1. Now I do 2. 1 comes down. 2 times 1 is 2. Add those down, get 1. That's 2. Negative 20, and then multiply negative 4. Is that it? Is that the one? That works. So just to remind you, what I'm doing is I'm bringing 1 down, multiplying 2 times 1, giving me 2. Add down, that gives me a 1. Multiply 2 times 1, that gives me 2. Add down, that's negative 20. 2 times negative 20 gives me negative 40. Add down, we get 0. As soon as we get 0, we're done. Okay, let's translate this into an answer. So we're supposed to take the 2 out here and take the opposite of it, right? And then another set of parentheses using the numbers right here. So the 1 should go in front of a what? X squared. Why is it squared, not something else? Yeah, the original problem we were trying to factor was cubed. 1 less than that is squared. So it's always 1 less, right? Plus what? 1x, so just x, minus 20. Okay. But, I know I'm kind of at the bottom of the screen here. The remaining quadratic here can be factored using AC method or something like it. So x minus 4 plus 5. So I do expect that, right? I do expect that you could get that. Yeah, now I need to go back up. Let me look it back up where I was when I went to synthetic division, which was way up here in red. And so I had this blue part. So I'm going to squeeze it right underneath this. It was negative x squared, but then everything here broke down to be x minus 2, x minus 4, x plus 5 equals 0, right? It should be it, right? Yeah. Okay, so I'm going to have to go to a new page. Any questions, though? I have negative x squared, x minus 2, x minus 4, x plus 5 equals 0. Now I'm going to set each of these equal to 0 and determine if I cross or bounce. So the first one is 0, 2, 4, and negative 5. The powers that I have on these, squared means bounce off, first power, cross, and then first power, cross, first power, cross. Yes. Okay, good. I'm glad you asked because I was thinking, I wonder if anyone has a question on that. Okay, what you're doing here is this. You're basically saying, when is negative x squared equal to 0? And you look at that negative in front as being a negative 1. Now just get rid of the negative 1 by dividing both sides by negative 1. So that tells you that x squared must still be 0, because 0 divided by negative 1 is still 0. And then, when you say some number squared has to be 0, that means x has to be 0. And another way you could do it is say, okay, take the square root on both sides. So x must be the square root of 0. Well, plus or minus, doesn't matter. Square root of 0 is 0. By the way, is 0 a positive or a negative number? It's neither. It's neither. It's neither. Is it even or odd? It's even. Mm-hmm. It's even. All right, let's draw the graph. Did I answer your question? Okay. I start by putting what here? X-intercepts, right? 0, 2, 4, negative 5.
Wait, why is 0 in
I just did that right here. Because it was one of these. Set it equal to 0, you get this. Right, that x squared was from the very beginning. We factored it out. All right, what do you do after you put in your x-intercepts? Left to right behavior. So the left side goes up, the right side goes down, correct? Like that. Now what am I supposed to do at negative 5? Cross through, so I'm going to go ahead and cross through here. I come back up and I have to get to 0 and bounce off of it. So I will bounce off. Then at 2, cross through, and then come back through, cross through at 4, and then continue on to the down. Just make sure I think I graded everything y'all turned into me last time. Let me see. Y'all pass this back in a little while. I have a lot of stuff to pass back, actually. I noticed that some of you would get all the x-intercepts were correct. Your left and right hand behavior was correct. Your bouncing and crossing was even correct, but you know, some of you would do something like, I don't know, like just come through and come back down and then bounce. Or you can only cross the x-axis at the places you found are x-intercepts. Don't be going across any other places. You can't just like draw wiggles whenever you want them. They have to actually go through only where you find them. All right, that's it. So these are taking about 15 minutes a pop, right? That's what it's been. So that brings us to the last type of problem. And your favorite. F of x equals... How about I sent a bunch out, right? Why don't we just do one that you might have a question on? Anyone? Which one? Okay, what was 3? Minus 16 over x squared? No. Just over x squared? Like this? That's it? Number 3? Okay. I don't know. Are you looking at a different one or?
No, maybe I just need to write down.
Okay. All right. Starting with the numerator. It's x to the 4th what? Okay. Over. Okay. Ooh. All right. Step 1, A. Factor completely. So what I'm going to do is I'm going to take the numerator.
Is this also a polynomial? Is this also a polynomial? Like,
No, yeah, this is a rational function. Yeah, sorry, I should have pointed that out. This is a rational function. You can tell because it's a fraction, right? Polynomial divided by polynomial. All right, factoring the top, you get x squared. I'm pulling a GCF out, and that leaves me with x squared minus 16. Yes? Now, I already know why this is a question for you. You can factor that further also. I'll do that on the next step. The denominator factors to be x minus 6. No. And then x plus 2. Yeah, okay. But the numerator factored to be x squared, x plus 4x minus 4 because that was a difference of squares. Who would do such a thing to you? X minus 6, x plus 2. Any questions on that? Okay, here we go. It's completely factored. Step B, cancel any common factors. We do not have any common factors, right? Y'all know what I mean by that, right? Like if there was an x plus 4 on the top and the bottom, we could cancel if they were the same. And I told you it's not going to happen in this class. I choose to do that. Some instructors do it. I don't. All right. Part B, I'm skipping. So part C is to find the x-intercept. So set the numerator equal to 0. So I set x squared, x plus 4, x minus 4 equal to 0. And you should get some answers here. I'm just going to put them on the side. What are they? 0, negative 4, and positive 4. Hey, I was looking back at some old college algebra tests that I used to give a couple of years ago. And when I would give rational functions, right, the numerator and denominator would both be something you couldn't factor without using synthetic division. Isn't that pretty painful? Isn't that mean? This was here. This is a long time ago. I don't know. Okay, questions on those? you'll skip part B on, well, I want you to at least look and say, yeah, there's no common factor, so yes, I'm skipping it. Step D, find the vertical asymptotes, set the denominator equal to 0. So remember, these were our x-intercepts. Now I want the vertical asymptotes, so set the denominator equal to 0. That gives me two answers. They are 6 and -2. These are my VAs. E. Find your horizontal asymptote. What case do we have here? So go back to the original problem. Look at the degree of the numerator, which is what? 4. Degree of the denominator, which is 2. The numerator is bigger than denominator, isn't it? So we're in case 2. No HA. Now hopefully you remember whenever this happens that means the left side's going to go up or down. We don't know yet. And the right side's going to go up or down. On the test though, it could be any of the 3 cases. So don't think just because I'm giving you no horizontal today, that you chose that problem, right? So it could be any case. So be comfortable with all 3. Because the degree of the numerator is 4, right? Degree of numerator, and the denominator is 2. And off of this cheat sheet on case 2, if degree of numerator is bigger than degree of denominator, you have no horizontal asymptote. See case 2? So no HA. Step F, plot the information. So I'm going to go ahead and start a graph on the next page. Help me out. X-intercepts, where were they? 0, 4, -4. 1, 2, 3, 4. At 4, -4. Okay, those are dots, right? Those are x-intercepts. Okay, then I have vertical asymptotes. Where? -2. -2? -2? Okay. -2 and +6. Vertical asymptotes are dotted lines. And remember what I said about if you ever have your vertical asymptote cross through the y-axis to do those little diagonal dashes? All right. Okay, horizontal asymptotes, we don't have any. So this is all the information we have to draw the graph. So now we need test points, right? The test points that I'm going to choose have to be on each side and in between all the x-intercepts and vertical asymptotes. You should always have one more than the total number of x-intercepts and vertical asymptotes together. So how many x-intercepts do we have? 3. And then verticals, we have 2. So we should have a total of 6 test points. So something to the left of -4, like -5, that's going to be a test point. Something between these two, -4 and -2, like -3. Something between -2 and 0, so like -1. Something between 0 and 4, something like 2. Between 4 and 6, something like 5. And after 6, something like 7. Oh yeah, I have no idea why I did that. This vodka is strong this morning. I'm kidding. Or am I? I'll pause the video real quick. Whatever it takes. Now this is that soda stream thing that I know some, didn't I ask some people, they said they didn't like it? Is that you? It's that where you make your own sodas. It's this is like a Red Bull version of whatever. So it's cheap. I mean, I just have it in my office and I just make it before I come to class. Hey, yeah, you have to buy the mixtures in the carbon. No, what's in there? Yeah. All right, I'm wasting time here. I should be plugging in points, but I was thinking you'd be doing that while I'm telling stories up here. So you're plugging away on your calculator, or how are we going to plug these points in? We have to test now all of those points. So f of -5. Now I showed you a short way of doing this before, right? Yes? What's the short way? Using the factored out one? So maybe I'll write the factored out one over here. It was x squared, x plus 4x minus 4. And then it was over x minus 6, x plus 2, right? That was it? Something like that? Now if I plug -5 in, I can plug -5 into the x squared, then into here, then into here, then into here, then into here, and then just figure out what all those multiply to be. So -5 squared would be what? 25 times, now -5 plus 4 would be -1. -5 minus 4 would be -9. All over -5 minus 6 is -11. And then -5 plus 2 is -3. On the top, it's basically 9 quarters, isn't it? 9 quarters in your pocket is how much money? 225. So 225 over 33, which is approximately what number? 6.8. Okay. Now plug in -3. -3 squared is 9. -3 plus 4 is 1. -3 minus 4 is -7. Over -3 minus 6 is -9. And -3 plus 2 is -1. You all understand what I'm doing? No one has a question? Ooh. -63 on top. 9 on the bottom. Hey, those 9s, that's just -7. I could have canceled those 9s, but. All right, next test point, -1. F of -1 is, let's see, -1 squared is 1. -1 plus 4 is 3. -1 minus 4 is -5. All right, -1 minus 6 is -7. -1 plus 2 is 1. So -15 over -7, which is approximately 2 point. Right, 2 point something, right? What's 1/7? I can't. 1/7. Okay, so 2.14. All right, 3 more to go. 2. So 4, 6, -2, -4, and 4. And my 4's cancel here. -12 over, so is this 3? Okay, 3. 2 more. F of 5. 25, 9, 1, -11. Oh no, not -11. -1, 7. 225 over -7. 32 point, -32 point, okay, -32.14. And finally, f of 7. All right, f of 7 should give me 49. Geez, 11. 7, 1, and 9. It's a positive number. That's all I care about. It's a big number, but it's positive. 3,000 something? And then divide by 9? 17? Oh. Yeah. All right, 419, whatever. It's a big number. We're not going to be able to put that on our graph, right? It's going to be way off. But that's okay. That's all right. Let's plug everything in now. You ready? Come back up here. Let me draw some marks on my y-axis. I'll go up 1, 2, 3, 4, 5, let's say 6. 2, 3, 4. Oh, I didn't like that one. 4, 5. All right, so at -5, where are we? At -5, we are at 6.8. I think I'll do the graph in red. So -5, we're at 6.8, so I don't know, somewhere up here. At -3, where are we? -7, so we're, you know what? Can I count each of these tick marks by 2? 2, 4, 6. Is that all right with y'all? Okay, so I'm going to make that 6.8 here. -7, 2, 4, 6. -7 somewhere around here. F of -1, 2.14. Somewhere around here. F of 2 is 3. F of 5 was -32. Whoa, way out there, right? I'm just going to put a dot at the lowest part of my graph over there. At 5, I'm way down there. And at 7, I was off the charts, wasn't I? Okay, so I'm going to just put it way up here like this. All right. Now, I kind of messed up because I've got red dots and black dots, but all the dots are part of my graph, right? So where are you supposed to start at when you start to draw this thing? Far left point. So the first point I have is this one over here. I must go to the left, out of that dot, and to the right. So tell me where I have to go to the left. What was my left behavior? Did I flatten out to anything? No, I had no horizontal asymptote. So that meant I had to go up or down. Up, why not down? It would cross the x-axis. So it has to go up. Now, before you draw it, think about what else you have to do as you come to the right. What do you have to do when you come to the right? You have to come down to this point, right? And then you have to get down to this point. So make sure when you draw this, you know, kind of keep that in mind. You know you got to go like this, and then this is going to keep going up forever, isn't it? And then this is going to come down through this point. Now, as I try and go to the right, from that point, what happens? The barrier forces me down. So I'm just going to keep it nice. And what you don't want to do is this. You don't want to be like this. Okay, I'm going to come to the right and then like that. Because the graph's supposed to be nice and continuous and smooth. It's not supposed to go and have weird, sharp corners on it and things like that. So nice, continuous, smooth. There we go. Then you're supposed to jump over and grab your next dot, which is this red one. To the left, what happens? Goes up, right? Goes up. To the right, what would happen? Be careful here. It's going to go to 0, but where's it got to go from there? Where's your next point? It's up here. So I'm actually going to bounce off 0. I don't think we had one like this in class, so we are going to go up to the left. We will come down and bounce off 0, come back up to the next point here. Now from that point where? Back to the X-Intercept. Now where am I going to go when I get to that X-Intercept? Am I going to bounce again? Down. Oh. I've got to go down through it, cross through it, and then that asymptote is kind of telling me what's going to happen here now, right? That asymptote's going to force me down. Now I jump over, grab my next point, which is here. To the left, what happens? It's got to go up like this. Now I'm just doing a rough thing. And then to the right, what happens? Can't go down, right? Because I'll cross the x-axis. Can't do that. So I've got to go up again, don't I? So this is the way I'm going to draw it. Up to the left, up to the right. We're done. All right, folks. We finished up with time to spare. Look at that. Maybe we should squeeze one more problem in on the test, no? Yeah, now on now I may throw a bonus on here. Okay? But I'm not going to say what it would be. It would be another version of one of these problems, or possibly the falling object problem. Like you're dropping something and how long does it take to hit the ground? If I'm going to do any bonus, that would be what I do, because that's what I would put on this test if there were enough time. I do need to talk about just a couple of things on this test. If there are 4 problems, right, and we're going to say in no particular order, all right, you're going to have a quad standard, right? You're going to have a quad non-standard. You're going to have a poly, and you're going to have a rational, right? That's what you're going to expect. Now, these problems will not be equally weighted, which I know doesn't make you happy. Okay? The last problem, the rational function, is worth the most. I know. The question is, how much is the most? So let me just throw some numbers out here and see how you react. I'm thinking 40 here.
Oh my God.
I'm thinking, what do you think? I'm thinking these are both 15. Which would make this 30. Now that's just because, I mean, obviously the rational function requires a lot more work. So what I might consider you do on this test, what I would suggest you do, is when you get to the test, focus a lot of your energy on the rational and the polynomial first. Get those done correctly. You know, I would hate for you to do the first 2, get them perfect, and then the other 2 you can't figure out and you get a 30 on the test. It'd be better for you to get a 70 and not have enough time to finish one of the quads. You know what I'm saying? Yeah. So, there you go. See how you do Thursday. Review, look at the problems I sent home, that I emailed you. Look at those, and you should be ready. Good luck studying.